Dublab.
With me, your host, Dr. Yewande Pearse. It's the final month of 2020, and understandably, I think we are all absolutely exhausted and pretty much looking forward to this year being over. So therefore, it felt like about the perfect time to do an episode on fatigue. This episode was actually going to happen last month in November, but ironically, I was so fatigued myself that I couldn't quite get it together. So apologies for that if you tuned in and heard a rerun, but I'm really excited to share the show with you. So let's get started. Fatigue is best described as difficulty in initiating or sustaining mental and or physical activities. So have you ever felt that weird sense of discomfort, that overwhelming desire to rest and reduced motivation? Well, the chances are you were experiencing fatigue. Acute fatigue is a normal phenomenon that disappears after a period of rest. In contrast, long-term fatigue or chronic fatigue is sometimes irreversible, and the compensation mechanisms that you usually find useful in reducing acute fatigue are no longer effective. Imagine being hungover or jet-lagged or having the flu but worse, and for at least 6 months. That's chronic fatigue. So chronic fatigue is often caused by the prolonged accumulation of acute fatigue and contributes to various medical conditions and even death. Simply speaking, fatigue is caused by excessive mental or physical activities and acts as a sort of bio-alarm, without which we would eventually die. Now, a whole bunch of lifestyle factors have been related to fatigue, such as alcohol, drugs, excess physical activity, also a lack of physical activity, a lack of sleep, medications, diet, and a whole host of medical conditions, but scientists are still trying to figure it out. Simply being alive in the world sets us up for fatigue, but living in a world during a global pandemic is particularly fatiguing. Depressing news, days that blend together with not much to distinguish them, a general sense of doom and gloom. Even if the silver lining is that we have slowed down or have more time for rest and sleep, this can all really stress out our bodies, deplete our resources, and leave us feeling completely burnt out. In short, we are all experiencing change and unpredictability in our lives, and a lot of us are feeling particularly anxious. Besides how this is affecting some of our sleep, the overall burden of the pandemic is giving us a new form of fatigue called pandemic fatigue. However, on today's show, I'm not going to focus on that, although I'll link some great resources on the website. On this month's show, I'll be focusing on what fatigue looks like in the brain and speaking with my very special guest, Dr. Vikram Chib from Johns Hopkins University, about how fatigue affects our ability to make the right decisions and what we can do to try and interrupt those mechanisms. Stay tuned, more after this. Our brains make up roughly 2% of our entire body. But don't be fooled, because the brain is a metabolically demanding organ and burns up 20% of our energy reserves every day, which is way more than our other organs. If the brain fails to get the energy it needs, it'll start making compromises. The autonomic functions of the brain that are needed to keep us alive, like our immune system and digestive system, and even the parts of our brain controlling our fight or flight response, keep going more or less as normal. But the more sophisticated executive functions of our brain are what suffer first. Executive function involves working memory, mental flexibility, and self-control. It's what helps us focus our attention, control our emotions, see connections, gives us foresight, and helps us make good decisions. When our brains are depleted or fatigued, we cannot focus our attention, we react impulsively, we can't join up the dots, we can't see the consequences of our actions, and we tend to make very poor decisions. I want to just point out one important distinction. So sleep and rest are not the same thing. Sleep is an important part of the picture, but rest actually includes the mental, the spiritual, the emotional, the social, the creative, the physical, and the sensory, because we all use all forms of energy in our daily lives, and that energy can become depleted. So many of us are actually suffering from a rest deficit that all the sleep in the world won't resolve. So for example, when we're busy trying to support our friends and our family through a rough time, we don't need 8 hours sleep. We actually need to say no sometimes and take time to ourselves or time around positive, supportive people who revive us. And after staring at a computer screen all day for, say, 10 hours, what we really need is to ditch our technology in the evening. In trying to figure out the mechanisms behind fatigue, studies have shown a connection between how much we work our brains and our autonomic nervous system. So quickly, the autonomic nervous system is part of our peripheral nervous system and regulates involuntary physiological processes, including heart rate, blood pressure, respiration, digestion, and sexual arousal. And it has two branches, the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system prepares the body for the fight or flight response during any potential danger, while the parasympathetic nervous system inhibits the body from overworking and restores the body to a state of calm. Autonomic dysfunction has been associated with fatigue in people with chronic fatigue syndrome and multiple sclerosis, which suggests that autonomic activities are related to the mechanisms underlying fatigue. However, this association has been demonstrated only in people with specific diseases and not in healthy volunteers. It's also been shown that chronic fatigue is associated with sympathetic hyperactivity. So one study published in the Journal of Behavioral Brain Function in 2011 set out to connect the dots and determine whether there is a relationship between autonomic function and mental fatigue caused by a prolonged mental load in healthy humans. So it was quite a small study of only 10 participants, so it could definitely have used more volunteers, but the findings were interesting. So what they did was they got the volunteers to carry out a set of mental tasks for 8 hours, and they measured their autonomic functions before and after. As a control, they got the same volunteers to complete an 8-hour relaxation session 4 weeks before, so they could compare. What they discovered was that mental load reduced parasympathetic activity, and that prolonged fatigue-inducing mental load reduces parasympathetic activity even further, showing that reduced parasympathetic activity seems to be a characteristic feature of mental fatigue. In the study, they suggest that sympathetic hyperactivity based on reduced parasympathetic activity is associated with mental fatigue resulting from prolonged cognitive activity. This is actually quite interesting because increased sympathetic activity has been shown to play a part in motivation. This means that motivation against potential impairment of task performance caused by mental fatigue may contribute to the increased sympathetic activity observed during fatigue-inducing mental tasks. So that is a little bit of a brain twister, so let's take a break, let that all sink in, and after the break we'll be switching over to physical fatigue when I talk to Dr. Vikram Chib about the research he is doing on trying to understand how the nervous system organizes the control of movement and how resulting rewards, both internal and external, motivate our behaviors. My interview with Dr. Chib after this. Dr. Vikram Chib is BME Assistant Professor at the Kennedy Krieger Institute at Johns Hopkins School of Medicine. Before that, he was a postdoctoral scholar in biology and biological engineering at the California Institute of Technology. He earned a bachelor's degree in bioengineering at the University of Pittsburgh and a master's degree and PhD in biomedical engineering at Northwestern University. His research aims to understand how the nervous system organizes the control of movement and how resulting rewards, both internal and external, motivate our behaviors. Dr. Chib, welcome to Sound Science. It's such a pleasure to have you on the show.
Thank you for having me. It's good to be here.
How are you doing this morning?
I'm doing well.
You're in Maryland right now.
Yep, that's right. That's right. Yep. So not as sunny as where you are in LA, but the weather's not bad. The weather's not bad right now.
It's not so bad. Does it get pretty cold during the winter months?
It does get a little chilly during the winter. Not horribly cold, but cold enough.
I hate to say this at the moment. I'm really craving a bit of rain because we haven't had some for a while. And actually, I think there's a strange heat wave coming back. But it's getting chilly at night over here too. So I
Yeah.
can relate somewhat. So I'm so excited to talk to you about something that I think is on a lot of our minds, which is fatigue. I think this has been a particularly tiresome year, and we've all been feeling a little bit burnt out, fatigue, tired, or however we might want to describe it. But on this episode, we really want to focus on fatigue and how that has an influence on our decision-making capacity and the way that we feel when we are fatigued and how that impacts how we move forward in the world. So I have some questions that I'd love to jump into. We all feel tired, and sometimes we feel a bit low energy, sometimes we feel absolutely exhausted. But whichever end of the tiredness spectrum we find ourselves, sleep and rest usually does the trick. To feel fatigued, however, indicates something beyond tiredness. So scientifically speaking, what is tiredness and what is fatigue, and how is this linked to our behavior?
Right. So the idea of fatigue and tiredness, these things are all very, very subjective. So exactly how they're quantified and characterized is challenging, right? You can feel tired, right? You do a little exercise or something and you feel a little bit tired. But fatigue is more, you think of as is more of like a persistent tiredness, right? So something that's chronic and long lasting. So I might feel tired for an instant and fatigued over the course of doing a bunch of activity. Right. I would say this is semantics more than something that's well understood and well scientifically classified. And that's sort of what brings us to the study of what we do in my lab. So we try and basically take these very subjective ideas of tiredness and fatigue and try and use some computational modeling and analysis to basically have a more objective way to classify tiredness and fatigue.
So what you're trying to figure out is a way to quantify fatigue so we all subjectively can describe ourselves as fatigued.
Exactly. So there are a lot of neurological and psychiatric disorders in which, fatigue in quotes is a problem. So it's called a lot of different things: amotivation, fatigue, anhedonia, right? And the way these things are classified usually is a doctor will say to you, well, on a scale of 1 to 7, how fatigued do you feel? Right. And the challenge with that is it's hard to standardize across people. My 7 might be your 5, right?
Right.
And so in clinical practice, one of the challenges, and in biology in general, I'd say one of the challenges to understanding how your nervous system represents fatigue and behaviorally how you represent fatigue is this lack of a good way of understanding how to quantify fatigue, right? What is the scale to use to quantify fatigue, to quantify your feelings of effort? So in our lab, we look at motivation and we look at decision making. We use tools from behavioral economics. So actually behavioral economics is very much concerned about how people subjectively feel about money, right?
Mm.
And so, how does $2 feel for me versus $2 feel for you? Or how would $2 feel for somebody who's very rich? They might feel that $2 isn't that much money. Or somebody who doesn't have as much wealth, they might feel like, oh, well, $2 is a lot of money, right? And so behavioral economics uses choices under uncertainty, basically gambling. So if I can have you flip a coin and take some risky decisions, I can then create a mathematical model that will characterize your choices and give you an objective description of how you subjectively value money. Well, we can do the same thing for effort, and we can use that modeling approach to basically say, all right, I know for Vic, his computational parameter for effort is whatever it may be. And that means that in an absolute sense, he feels this fatigued or that effort is this much of a cost to him.
I see. That's super interesting how you take something that difficult to grasp and then find a quantifiable way of looking at it. And I really like the parallel with considering our relative perception of how much $2 is. Actually, I wanted to interview you for the show because I came across your recent Nature Communications paper entitled Neural Mechanisms Underlying the Effects of Physical Fatigue on Effort-Based Choice. And in that paper, you describe the structures and neuroprocesses in the brain that are involved in computing the value of effortful options and making effort-based decisions. So I'm really curious as to how you carried out this study or how you designed the study and what the most striking results were.
Yeah. So what we were looking at in that study is basically taking healthy participants, healthy human participants, and having them make decisions about whether they wanted to exert effort or not. So basically, we began by saying, flip a coin. One side corresponds to exerting a large amount of effort or no effort at all, or you could choose to do a small effort for sure. So basically take no risk, right? So one way to avoid effort in this scenario is to just take the sure option. The risky option, I should say, is a large amount of effort or nothing, right? So one way to avoid effort is I could say, all right, I'm going to flip a coin and hopefully it'll come out zero and I won't have to do any effort. But there is also a risk that you'll have to make a large amount of effort, okay? One way to avoid effort is to say, like, I'm going to take that risky option. The other option would be to say, look, I'm not going to take any risk. I'm just going to take the small sure amount. Because even though I have to do a small amount, it's not as much as I would have to take if I were to flip that coin and take the risk, right? And so people have their individual differences in risk preferences. And we can use a little bit of math to characterize it. The math isn't super important, but basically we had people make these choices, then we had them make repeated exertions to get them tired. And we asked them to do these same choices again. And what we found in our study is as you become fatigued, you become less willing to take risk to avoid effort. Basically, you take that sure option more, which kind of makes sense. You might say to yourself, like, look, I'm really tired. I don't even want to have to worry about,
Right.
taking a risk and having to take a large amount of effort. And that was interesting behaviorally, the fact that you would change your risk preferences as you became more fatigued. But what we were really interested in is what was happening in your brain. Like what's happening in your, neural architecture that makes you feel fatigued. So we put people in the MRI scanner when they were making these choices about effort. And what we found that was surprising was that those people that were less willing to take risks had less changes in their motor cortex, which is the area of the brain responsible for getting you to initiate physical activity. The less your motor cortex changes in response to fatigue, the less risk you are willing to take. From that, what we realized was that what's happening is the reason you feel fatigued is you're not able to appropriately understand the capability of your motor cortex. So one thing that could happen is you're fatigued, your motor cortex changes in response to the fatigue, and everything is in line. My choices change because my motor cortex activity changes in response to fatigue. Another possibility is that it's sort of a dyshomeostasis. It's something out of whack between what I think I'm capable of doing and what I actually can do. And so in that case, you would expect motor cortex doesn't change at all. And because motor cortex doesn't change at all, and I don't appropriately tune my neural activity, I feel very tired. That was what was very surprising to us. We thought that, oh, well, your choices will just reflect what your neural activity was. And instead, you feel fatigued because you don't really understand what you're capable of, or what your brain doesn't really understand what it's capable of. Does that sort of make sense?
Yeah, that makes a lot of sense, but I agree with you. It's really surprising and kind of not what you would expect, which begs the question, is it that being fatigued impacts your neural activity or that your neural activity impacts your fatigue?
Uh-huh.
Which
Yeah.
direction is it going?
Yeah. And so we can't really say. The way we set the experiment up is we fatigued people and then we took neural activity. And
Got it.
so we think that it is the way that fatigue is infecting the neural activity. But MRI is like this correlational measure. You're just correlating brain activity with some behavior. So it's hard to know like what causes what. We can't make any causal statements, right? And so right now we're thinking to ourselves, all right, how do we design some experiments to sort of causally manipulate this behavior, right? So we have some techniques to use where we use non-invasive brain stimulation. So there's a technique called transcranial magnetic stimulation, which basically allows you to take a stimulator, place it over the scalp, and create reversible lesions where you
Mhm.
send current through the stimulator. It induces a magnetic field that creates like a virtual lesion in the brain. So what we can do is we can use that over motor cortex. So what if I caused a virtual lesion over your motor cortex such that I increased or decreased excitability in the motor cortex? How does that then influence your choices? And so we're doing those experiments. The verdict is still out. We don't have any definitive answers yet, but we're beginning to try and answer the question that you just answered, like, well, what comes first, right? Like, is it your brain that's influencing your fatigue or fatigue that's influencing your brain? I suspect it's going to be a combination of these things, right? But yeah, we're trying to do the experiments to figure out that exact question.
Wow, that is super fascinating. And as you were describing it, my next question was going to be, what did you find out? But I guess we have to we have to hold tight and watch this space. Just one more question about the study setup. How did you fatigue the participants? What exercise did you
Yes, I'm
get them
sorry.
to
Yeah,
do?
so the type of effort is important, right? So you could have different types of effort and different preferences for different types of effort. For example, a marathoner might not like to, go to the gym and bench press, whereas like a weightlifter might not want to do marathons, right? And so we needed
Mm.
to figure out, okay, how do we get a standardized effort that will work across all people and that we can tailor so that the maximum is characterized for each person. And so the effort that we used, it's a little bit abstracted, but the effort that we used was a grip task. So gripping a hand grip sensor. Participants could grip this hand sensor, and we used that as the type of effort that they were using. And then they were making choices about whether they wanted to do a lot of gripping exertion or a little amount of gripping exertion.
Following the fact that they had already exerted this physical effort.
Yes, that's correct.
So, to be clear, are these structures that are involved that you found through the fMRI study, are they involved in both physical and mental effort? In other words, does physical fatigue impact decisions about whether or not I should start that bit of work this evening as much as it does a decision to take a spin class if, say, in the morning I had fatigued myself by going for a run? The area you were talking about was the motor cortex. I'm just curious about how this affects other areas of the brain. Were you able to identify that at all?
Yeah, so that's a really good question. We were focused on motor cortex because that is responsible for physical effort. But another area of the brain that came online related to decisions about effort was the insula. And the insula is related to sort of your interoceptive sense. So understanding things about your bodily state, which is important if you're fatigued, right? If I'm fatigued, I need to sort of pull my internal state and say, okay, what do I feel like? And those feelings could then channel into how I make decisions about effort, right? If I feel fatigued, then I might decide, not to exert effort or not go to my spin class, right? And the question that you asked, I think is there crosstalk, or what are the common and distinct cognitive and physical representations of effort? And then is there crosstalk between them? And I will say again, have me back again, because hopefully we will figure that out. So we're actually running a study right now to look at what is the crosstalk between cognitive and physical effort. Why is it that after a long day of work, sitting at my computer, analyzing data or doing some cognitive effort, that I might feel fatigued and not want to go to the gym and do physical effort? That's something, anecdotally we all feel. And so we're trying to figure out, how does that happen? Why is it that cognitive effort and physical effort can sometimes have this crosstalk and lead you to, even though, I've been fatigued in one domain, which is, say, cognitive effort, it makes me feel fatigued in another domain like physical effort. And we're still trying to figure that out. And surprisingly, there really isn't much out there that is known. I suspect that what we're going to find is this region of the brain, the insula, which monitors your internal state, is going to be really important in both of those types of effort and fatigue associated with them. So you having an understanding of your internal state, whether it's cognitive fatigue or physical fatigue, is going to be very important and guide how you make decisions about exertion. We see some anecdotal evidence of that. If you look at studies of effort-based decision-making, not in a fatigued state, whether it's cognitive fatigue or physical fatigue, you see sort of a network of brain areas that comes up. Anterior cingulate, which I haven't mentioned yet, but shows up, and as well as insula, which I have mentioned. And so I think you're going to see a sort of a common network that's associated with cognitive and physical fatigue. And then that might connect to networks related to the type of effort you're doing, such as like if you're doing a motor effort, motor cortex, right? Or if you're doing a cognitive effort, maybe more prefrontal cortex. But that's still to be seen. So we still need to figure that out.
I can't wait for I can't wait for those results. I think there's so much in it, even in terms of thinking about the balance of how exercise is meant to be positive for many reasons and how that might impact on like your decision making if you have cognitive fatigue and where the nuances. I think it's just such an interesting area of research. And I was surprised too to see how little there is on this topic and yet how much it impacts so many of our lives, both in health and also in disease. fMRI is a really, really powerful tool, and it's one of my favorite tools in science and sort of understanding the brain. So when I read the study, I saw that you had carried out the study with 30 male and female identifying people, aged between 18 and 34, and they all showed a similar response, which is how you were able to come to this conclusion. So my question is, why do you think the brain has evolved to respond to fatigue in this way? Does it make sense for the brain to find it more difficult to make effort-based decisions when it's fatigued? What are your thoughts on that?
Yeah, that's a good question. So I think that the fatigue finding that we find, this dishomeostasis between what you think you're going to do, what you think you're capable of, and what you're able to do, I actually think that that is probably sort of a maladaptive thing. Because basically what that means is that you're out of whack, right? Your brain is doing one thing or thinks you can do one thing, but you really can't. So I think the animals that are probably going to do best are the ones that are able to sort of tune appropriately, right? And so if you think about it, those people that are less fatigued and are able to tune their motor cortex appropriately can, in the long run, do more effort, actually, right? Because they'll say to themselves, oh, I tuned down my motor cortex. I don't feel as fatigued. I can actually keep and persist a little bit more. Maybe I'm better at sort of then scaling back my effort to be within my bounds of what I'm able to do. Now, those people that aren't able to tune it down as much might say to themselves, I'm just too tired. I give up. I'm not going to forage for food anymore. I'm not going to run away from the prey anymore, or what have you. So I think that this tuning is important, and being able to appropriately tune your motor cortex is probably going to be very important for survival, as you suggest. One thing that's very interesting is these choice biases, just generally for rewards, have been found. So there's this idea of loss aversion, basically, that where you value losses more than equal magnitude gains. It's a phenomenon in behavioral economics. It's been found in people, and people tend to value losses twice as much as gains. Meaning, if I wanted to flip a coin and say one side corresponds to winning an amount, the other side corresponds to losing amount. The only way I begin to start taking that gamble is if I tell you, you have the possibility of winning $4 and losing $2. In that case, the gains really outweigh the losses, right? There's a woman, Laurie Santos at Yale, who's taken monkeys and set up a market for these monkeys where they trade coins for, tokens for fruit. And what she finds is that using that currency, she can give them choices and figure out how loss averse they are. And they tend to have the same loss aversion parameter we do. They value losses twice as much as equal magnitude gains. So, which is really interesting, right? Because it means that it suggests that this is something that could be hardwired or evolutionary. So I think these biases are, as you suggested, could be an evolutionary thing that is really driving our behavior, right? And the loss aversion idea makes a little bit more sense because, in the wild, if you lose, you die, right? There's no losing $2 in the wild, right? It's like, if you lose, it's over. So then it really makes sense for you to be loss averse, even though in our daily lives, it actually doesn't make sense to be loss averse. In the long run, you being loss averse makes you lose out on a little bit of reward, right? But we have this bias that seems to be hardwired, and it could be the same thing for effort. Your question about, the evolutionary ideas behind this is a very interesting and important idea. And I think we don't know much about that evolutionary aspect in the context of effort, but people are beginning to know more about it in terms of motivation and reward.
The ideas around maladaptive behaviors and how they look in modern life, I find really interesting. In this study, I don't think I read exactly where the participants were from, but I'm assuming they were based in the US. So One question, is that right?
Yeah, that's correct. Yeah.
Okay, so one question that came up in my mind is I wonder if cultural differences for fatigue tolerance would result in different fMRI off the back of the question of the fact that maybe our brains have all evolved to respond to fatigue in this way. Do you think that there may be some difference if you look at participants in different geographical locations from different cultures?
Yeah, I mean, it could be. I don't know much about different cultural tolerances for effort, but one thing that does come to mind is the difference between different types of people. And actually, that actually relates to sort of why we're doing this research. And basically, you could think that there are people that like to exert effort,
Mm-hmm.
and there are those who do not. Right. And so the question is, where do those individual differences come from? You make a good point. One could come from societal differences, right? Another could come from individual differences in brain chemistry, for example. And so
Right.
the reason that we did this study and the reason that we're motivated to do this is to use these well characterized tasks to classify fatigue and decisions about effort in patient populations. For example, people with psychiatric conditions. Psychiatry, the way it works now is, you go to the psychiatrist and they say, Vic, how are you feeling today? And I might say, oh, well, I don't feel like getting out of bed and I feel very fatigued. And so they'll say, well, okay, I checked this off and I checked that off. Okay, I think you're depressed, right? And
Right.
what you could do with a suite of paradigms like what I've described here and computational models to describe that behavior is we could then classify different types of people, right? And classify different maybe mental illness or different psychiatric conditions. And a component of that is going to be societal, as you mentioned, but another component of that could be issues with neurochemistry that could be helped to be treated with medication or cognitive behavioral therapy or things like that.
That's really interesting. I like the application of this research and putting it into context like that, especially when thinking about psychiatric conditions. I guess my final question is sort of along the same lines in terms of application. Your research provides some really great insight into how feelings of fatigue are processed in the brain. But I wonder what we can do in our daily lives to sort of hack these neural mechanisms, if you like. Do you think there is a way to influence how our brain decides how much and what kind of effort to make to overcome fatigue? Or is it more like what you're saying, that we just are different and then we just need to operate with an understanding of those differences?
I think that you probably can understand these predispositions for fatigue and use
Hmm.
cognitive strategies maybe to overcome them. So one of the things, this is another avenue that we're looking at now is, are there way to reframe tasks so that, they feel less effortful? So even though you're exerting the same amount of effort and you have the same sort of energy output, they feel to you less fatiguing. And so you could think of reframing strategies. This is one of the things that we study in the lab and have studied in the lab related to reward. So we've done things where we have people frame things as a gain as opposed to a loss and see how that influences motivation. But I think that you could probably frame things in terms of reframe effort expenditure as well and see some benefit. And so one trick that traders, like financial traders, often use to make themselves make more rational decisions is to, rather than thinking about individual decisions that they're making, they're told to think about their portfolio of decisions over the entire day. And this tends to make, and we talked about loss aversion before, this tends to make people feel less loss averse and then make more rational decisions. So you could think of it using a same strategy for physical effort. Don't think about this single trial that you're doing of effort or this single repetition of, whatever exercise you're doing. Let's say it's bench pressing. Think about this is only one in the portfolio of 20 reps that you're going to do, right? And by spreading out how impactful that effort is going to be on the overall suite of exertions, you might be able to make yourself feel like it's less costly. Reframing in that way is something that we've shown to work for getting people to perform well under pressure when large incentives are on the line. And I think a
Hmm.
reframing of this portfolio strategy of thinking not of the single bout of effortful exertion, but over sort of a bout of exertion in a portfolio of exertions, could get you to sort of reframe and make more rational decisions about the exertions that you do.
Interesting. And I guess this kind of is similar to the idea of chunking if we're talking about sort of
Yeah. Yeah.
like in learning, for example. And that's why I think it'll be so interesting to see how physical and cognitive fatigue are related and how they impact each other. Just thinking about the physical effort to get up and go and do something that actually might be quite a cognitive task, I think is fascinating. And I think there's so much application for people, whether in health or in illness, for the findings of your study. So I'm super excited by the work that you're doing, and I would love to follow up further down the line and find out where you get to with your conclusions.
Yeah, definitely. Thank you very much for having me. I really appreciate it.
For the audience who want to follow up on your work after this episode, is there a website that they can go to? Or
Sure, they could go to my lab website. It's chiblab.jhu.edu.
amazing. Okay, that's great. I'm going to pop that on the website in the show notes so people can look that up and keep up with your research as well. Thank you so much for being on the show. It's been an absolute pleasure speaking with you today, Dr. Chib.
Great. It was great talking to you too. Thank you for having me.
That's the end of the show. That's the last show of 2020. We made it almost. What a year. Well, I hope that this episode has encouraged you to take the rest you need and the sleep that you need when you can. I want to say a huge thank you to everyone who has tuned in to the show this year. Honestly, it means so much to me, and I wouldn't be doing it without your support. And I really appreciate you. If you wanted to give me a little Christmas present virtually, then it would be amazing if you were to rate the podcast or leave a positive review, because it really helps. And just a reminder that actually there is a difference between the show and the podcast. So the show, which is what you're listening to now, has all of the great music because it's the wonderful Dub Lab. But the podcast is edited so that it doesn't have the music. So it is all about the science. So if you want to get straight to the point and listen to the science, then tune into the podcast, which comes out a week or two afterwards. If you want the music, then you need to go to the Dub Lab archives. And if you're sharing the show, then please let people know as well. Yeah, that's about it, I think. This is a really difficult time of year for a lot of people, especially those who can't be with their families. So I'm thinking of you, and I am looking forward to seeing you on the flip side. Apologies for the noise in the background. I managed to get through a whole home recording almost without noise disturbance. But my cat, Stedman, has decided that the foil that he's found on the floor is extremely fun to play with, and it's making a whole lot of noise in the background. So I'm going to just leave that in there. Stedman. Until next time, take care. Bye.